Okay, this is the last section, or the last half of the last section for Aubrey and Ellie. I don't know where Ellie is. But yesterday what we did this like really ugly thing yesterday, right? Where we took the original matrix, and to find his inverse, right? Like to find this guy's inverse, we take and we augment him with the identity matrix, which has diagonal ones and everything else is zeros, okay? And then we did all the reduced row echelon stuff to try to get this side to be the 1, 1, 1 with all the other zeros. And what ends up happening is as soon as we get to that point, right, where we get 1, 1, 1, all the things, this guy is what the inverse is, okay? Now, how do we use that to solve anything? Well, here's the deal. Let's say we have example 4, and we've got this guy, right? I'm not going to put him in matrix format, but this guy right here, we're solving for x and y, right? We know like a bunch of different ways of doing that. Like you can do substitution, elimination, all the things, right? Okay, so what I'm going to do is I'm going to say that this is matrix A over here, and this is matrix B over here. So the solution is B, the x's and y's are A. Got it? Okay, so if I have A is 2, -3, 1, 5. Okay, I'm going to take A, and I'm going to augment him with the identity matrix. So 1, 0, 0, 1, all that stuff, right? Okay, that's what I'm going to do with A. And I'm going to find A inverse. So step number 1 is find A inverse. Okay, so I've got that guy. And I'm going to try to get, I have to do the reduced row echelon stuff to get him to be to find the inverse. Okay, so here he is now. All right, which number are you going to pick on first? Two. We got to get the 2 to be a 1, right? How do I get that 2 to be a 1? Remember? How do we get 2 to be a 1? Divide by 2, right? Okay, we're going to take that top row and we're going to divide by 2. So I'm going to put him down over here. That bottom row is going to stay 1, 5, 0, 1. But the top row now is going to change to 1, -3 over 2, which is kind of gross. 1/2, and 0 divided by 2 is 0. So that's what he becomes. The pink row is the one that is changed. I'll try to use the same colors every time. Okay? All right, now, which row are you going to pick on? Or which number are you going to pick on? This one down below here. He needs to be a 0. How do you get him to be a 0? What?
Something row 1.
Yeah, we got to take something times row 1. What will cancel with that one? A -1. So I've got to multiply this guy by a -1, right? Okay, I'm going to do that at the top. So 1 times -1 is -1. -1 times 3/2 is positive 3/2. This will be -1/2, and this guy will be 0, okay? Now, that top row is going to stay 1, -3/2, 1/2, and 0. Okay, but that bottom row, we're going to add those together, right? So this green row and this row, if we add those together, 1 and -1 is 0. That's what I want to have happen, right? What's 3/2 plus 5? 3/2 is 1.5, by the way, if you want to do it as a decimal. So 6.5, sure. Let's do this as -0.5. I'm going to convert to decimals. And let's go with, if I add these two together, that's 1, right? Okay, so now we're here. Holy moly. Okay, now what? Which one do we pick on now? What? Not yet.
6.5.
We got to get the 6.5 to be a 1, right? Okay, how do I get 6.5 to be 1? Divide by 6.5, right? Okay, so that top row is going to just chill. 1/2 and 0. And the bottom, I'm going to divide by 6.5. 0 divided by 6.5 is 0. Oh, I'm going to do my colors. 6.5 divided by 6.5 is 1. What's 0.5 divided by 6.5?
Not a pretty number.
Not a pretty number. What is it?
-0.0769.
You're kidding me. 1/2 divided by 6.5 would be 13 halves. So it's 1/13, right?
Yeah, that's-
If I multiply 2 over 13,
Yeah,
1/13.
-1/13.
That's disgusting. -1/13. Okay, that's gross. I'm gonna leave him as -1/13. Otherwise, we'll lose the integrity of the decimal. Okay, 1 divided by 6.5 is 1 divided by 13 halves, so 2/13. That is so disgusting. Okay. All right. Now, last, we got -3 halves. What did you say?
Take row 2 times 1.5
Take row 2 times 1.5 or times 3 halves, and I'm going to add it to row 1, right? So if I do that, 3 halves times 0 is 0. 3 halves times 1 is 3 halves. Okay, 3 halves times -1/13 is -3/26. 3 halves times 2/13 is 3/13. That's so disgusting. Okay, whatever. Okay, bottom row is going to stay the bottom row, because he's already 0, 1. -1/13, 2/13. Okay, but now I'm going to add this green guy to this top guy. All right, so 0 and 1 makes 1. -3 halves and +3 halves makes 0. Okay, so I'm almost there. All right, now I got to figure out, I know that the 0 and 3 over 13 is 3 over 13, so I'm going to leave that. Okay, but 1/2 and -3/26. 1/2 and -3 over 26. My common denominator
5/13.
is 26. And if I multiply that by 13, this is 13/26 minus 3/26, which is 10/26, which is 5/13. You betcha.
That's not okay.
Holy moly. Okay, so what did we just find?
The inverse.
This is A inverse. Yay! Okay, that's really gross. All right, now here's the deal. Are you ready? That's the inverse. So disgusting. Okay, but the deal here is, look up to this guy right here. Okay? If this is A, like this guy, I can write him as 2, -3, 1, 5. That's what the A vector, or the A matrix is. Okay? If I multiply him by the XY matrix, right, like this, okay, he gives me the B matrix, which is 4, 2. Like, that's another way of writing this whole thing in matrix form, right? If I take A times the XY matrix, he gives me 4, 2. That's what this guy says, right? So in other words, A times X gives me B, okay? So if I want to get rid of A in order to just have X, what I do is I invert. I take A inverse times both sides. Well, what is A inverse times A right here? He goes away, right? And just gives me X. So now that I have A inverse, I need to take him times B, and B is that 4, 2, right? In order to get the X matrix, or in order to get the solution, I guess, right? So now that I have the inverse, I'm going to take him times B, right, to get what the X is, right? So here is A inverse, that really disgusting, gross guy. 5 over 13, 3 over 13, -1 over 13, 2 over 13. That guy, I have to take him times the B matrix, which was 4, 2. That's going to give me the final answer, right? Okay? Now, this is a 2 by 2. This is a 2 by 1. Can I multiply these together? Yes, and the answer will be A, 2 by 1. Okay? All right, I'm going to take these guys times these guys. What's 5 over 13 times 4? Like 20 over 13, right? 5 over 13 times 4. What's 3 over 13 times 2? 6 over 13. Okay, that is 20 plus 6 is 26 over 13, which is 2, right? 26 over 13 is 2. Hey, that comes out nice.
The other one's
Okay,
0.
okay. So we take these guys times these guys, right? 5 over 13. 5 over 13 times 4 is like 4 over 1, right? Okay. 5 times 4 is 20. 13 times 1 is 3. So 20 over 13, okay? Then we have to take 3 over 13 times 2, right? So 3 over 13 times 2 over 1, would give me 6 over 13. So 6 over 13. I add those two together, and that's 26 over 13, and 26 divided by 13 is 2.
So the 5 over 13 doesn't multiply by the bottom.
Correct. Correct. Because it's 4 over 1, technically. So the 13 times the 1. Yep. Okay, now if we do the other one, this guy right here times 4 over 2. So I've got negative 1 over 13 times 4 over 1, which is negative 4 over 13. Okay, then I have 2 over 13 times 2 over 1, which is positive 4 over 13. If I add those two together, 0. Look at how nice this answer was in the end, but how messy it was in the middle. Okay, now what does 2, 0 do? That is the place where these guys cross, which you could have done with substitution and elimination. But it just goes to show you that matrices like work like that, right? And they're ugly.
Hate them. They're stupid.
Okay. All right. This is a 3 by 3,
We have to do the same thing.
and I don't want to do that. Let's, instead of doing a 3 by 3, because I don't think I make you do a 3 by 3 in your homework, do I? Let's do one of the 2 by 2 on your homework.
That's a great idea.
That's a great idea. Show that the matrix inverse. Okay, hold on. Where are we at?
We should do 14.
Solve using the inverse. So 34.
That's 34.
34. Let's do 34. Okay, so the A matrix on 34 is, if this is A, the A matrix on 34 is 1, 1, 1, negative 1. Yeah? That's going to be nice when we go to try to do him, okay? The X matrix is my XY, okay? And he is equal to the B matrix, which is 5, negative 1. Yeah? That's what the B guy is. All right, we have to figure out what A inverse is, right? So 1, 1, 1, negative 1. I'm going to augment him with the identity, which is this guy. And then we're going to reverse them all. Okay? All right. Here we go. I want to pick on this top one first, and he needs to be a 1. But he is. So that's nice. Okay, then I got to pick out this bottom one, and he needs to be a 0. How do I get him to be a 0? Top row times negative 1. Okay, I'm going to do that up here. So top row times negative 1 is negative 1, negative 1, negative 1, 0. Okay? Now when I go, that top row is going to just chill. 1, 1, 1, 0, right? But the bottom row is going to be me adding this guy and this guy together. Okay? So 1 and negative 1 is 0. Negative 1 and negative 1 is negative 2. Negative 1 and 0 is negative 1. 0 and 1 is 1. Okay.
So now we need to do
Now we got to pick on negative 2. He needs to be a 1. Okay? And how do I get him to be a 1? Nope. That will make him be 0. Right? If I add them together. I'm going to divide by negative 2. Right? On the far end, these two guys added together. 0 and 1. Yeah? You're fine. Okay. So bottom row times, or divided by negative 2. Okay, that top row is just going to chill. He's going to be 1, 1, 1, 0. We're not doing anything with him yet. But the bottom row, if I take him divided by negative 2, 0 divided by negative 2 is still 0. Negative 2 divided by negative 2 is 1. Negative 1 divided by negative 2 is just 1/2. And positive 1 divided by negative 2 is negative 1/2. So that's what he becomes. Okay, we only have one more step, guys. This is exciting. Well, for this part, anyway. I'm going to pick on this one. He needs to be a 0. How do I get him to be a 0? I take the bottom row times the negative 1, and I add him to the top row, right? If I take the bottom row times negative 1, he is 0, negative 1, negative 1/2, positive 1/2. Okay? All right, the top row, or the bottom row is just going to chill. 0, 1, because he's all done. Okay? Now my top row. Am I going too fast? Okay, this row right here added to this row right here. So 1 and 0 makes 1. 1 and negative 1 makes 0. What's 1 and negative 1/2? Negative 1/2, or positive 1/2, right? 1 minus 1/2 is 1/2, okay? And 0 plus 1/2 is 1/2. Okay, so we just found A inverse. He is this guy. This guy is A inverse. All right, now what do we do with him? If I want to find the X matrix, if I want to find this guy,
Times.
I have to take B times A inverse, right? So I gotta take what I just got times 5 negative 1, right? Okay, so I'm gonna write them out right here. 1/2, 1/2, 1/2, negative 1/2. I'm gonna take him times 5 negative 1. All right. He is a 2 by 2 and times a 2 by 1. So I should end up with a 2 by 1, right? Doop, doop. Okay. All right, this guy and this guy. 1/2 times 5 is 2.5. 1/2 times negative 1 is negative 0.5 or negative 1/2. So that guy ends up being 2. Okay, bottom row. This guy and this guy. 1/2 times 5 is 2.5. What's 1/2 times negative 1? Positive 1/2 or positive 0.5, right? So that should end up being 3. So the answer to this is 2, 3. How fancy.
That's for 34.
That's for 34. You betcha. That was a little bit nicer than the one in the notes, I think, maybe.
Can we do 45?
Sure, we can.
Is this
Show that matrix inverse method cannot be used to solve each system. All right. So we're just going to start doing this one like we did 34, right? So here's my A matrix. He is 7, negative 2, 14, negative 4. Times the X matrix, which is XY, gives me the B matrix, which is 3, 1. Okay? So we would start normally by taking the A guy, 7, negative 2, 14, negative 4, augmenting him with 1, 0, 0, 1. That's where we start. This is where we start, 45. Okay. Am I doing okay so far? All right, what are we going to pick on first? 7 needs to be a 1, so we divide by 7. Yep. Okay, so I'm going to go down. If I take row 1, divide by 7, that's going to be really gross. He's going to be 1. Negative 2/7. 1/7 and 0. That's disgusting. But it's fine. Okay, oh, and the bottom row stays this. All right, okay, all right. We're going to end up with a problem here, which is a good thing because then we get to stop, right? All right, I'm going to pick on this guy. He needs to be a 0. So I have to take the top row times negative 14. Okay, so I'm going to do that up top here. Negative 14 times 1 is negative 14. What's negative 14? Negative 14 times negative 2 over 7. 28 over 7, which is 4. Or you can cross this out and make this a 2 and make that a 1, so that would be 4, right? So this is going to be 4. Okay? What is negative 14 times 1 over 7? Negative 2. Negative 2, and then negative 14 times 0 is 0. Okay. All right, my top row is going to stay that disgusting 1, negative 2/7, 1/7, and 0. But now my bottom row, I'm going to add this row and this row together. Okay, so negative 14 and 14 makes 0. 4 and negative 4 makes, negative 2 and 0 makes negative 2. 0 and 1 makes 1. We have a problem.
0, 0.
I have 0, 0. I can't make this a 1, right? Because even if I multiply by 1, it's not going to make it a 1, right? Because it's still 0. So here we have, can't do it. We cannot find the matrix inverse because we end up with a problem, right? Okay. There you go.
Can we look at 7?
Sure. 7. Okay, so it just says show that if I take the identity matrix times A, it ends up being the same as A. So I'm going to take the identity matrix times A. I guess it doesn't really matter what order you go in. You could take A times the identity matrix. So we're going to do it in that order just because they're right here. So you're going to do this guy times this guy. And he should end up being a 3 by 3, I think.
It's just the same.
Yep, you're just going to show that he ends up being the same as what the A is. Like this answer should be what A was to begin with. Yep.
Is this the last lesson?
Yes.
Okay.
Yep.
Wait, what are we supposed to do?
On 7, you just multiply, and show that this guy ends up being the same as what A was to start with.
Oh, okay.
So, what?
Are we, so, on 10,
So you're trying to see if they are inverses of each other. Okay? So what happens is if they are inverses of each other, you can multiply them together and they should end up being the identity matrix. That makes sense? Yeah. So if you don't end up getting that, then they are not inverses. Okay? Same thing with 14. Yeah. Okay. All right, I'm going to stop recording.